Hi, I'm Travis Connor, and this is Lab 3, Black Hole. In this lab, I observed the influence of gravity on a star and a black hole, as well as the influence of gravity on a spaceship, planet, and a black hole. To observe this event, I created two computational models in GlowScript. The overall purpose of this experiment is to find the unknown mass of a black hole, as well as the initial velocity of the spaceship needed to leave the surface of a planet and fly around a black hole. The fundamental principles used in this lab were Newton's second law and Newton's law of universal gravitation. The main result of this lab was that the mass of the black hole was 8.83881 times 10 to the 33 kilograms, and the initial velocity of the spaceship was negative 8.9 times 10 to the 6 for the x component, and 7.3 times 10 to the 6 for the y component, and 0 for the z component. For Newton's second law, F net is equal to the change in momentum over the change in time. F net can then be broken down into two components, F net parallel and F net perpendicular. F net parallel is equal to the motion of the object, and is the magnitude of the final momentum minus the magnitude of the initial momentum divided by the change in time, and then multiplied by p hat. F net perpendicular is equal to the change in momentum over time minus F net parallel. The total force acting on the object, or F net, also allows for velocity update and position update equations to be used. In this experiment, we used the magnitude of Newton's law of universal gravitation. For this experiment, F net is equal to the force of gravity, meaning that F net is not constant. Because of this, the average velocity will be equal to the final velocity. Also, F net parallel controls the speed of the object, and F net perpendicular controls the direction of the object. As for the system and surroundings, in experiment 1, the system is the black hole, and the surroundings is the star. In experiment 2, the system is the spaceship, and the surroundings are the planet and the black hole. The initial conditions for the first experiment are that the gravitational constant is 6.7 times 10 to the negative 11, and the mass of the star is 2 times 10 to the 30th kilograms. The change in time for each interval is 1 day, or 86,400 seconds, and t equals 0 at the start. The initial conditions for the second experiment include the similar conditions to the first experiment, but it also includes the mass of the black hole, the planet and the ship, and the velocity of the planet and ship. For the code for experiment 1, I set F net equal to dp dt. I then used the F net parallel equation in the code to find F net parallel. I started with defining p hat and the change in momentum over time. When those two variables were defined, I multiplied them by each other to give the change in momentum parallel. After, I used dp dt and F net parallel to find F net perpendicular. And at the end, I derived an equation from Newton's law of universal gravitation to find the mass of the black hole. And we can see from the results that the mass of the black hole is 8.83881 times 10 to the 33 kilograms. For experiment 2, I started by finding R, and then finding R hat, and then using those values along with the gravitational constant and the mass of the black hole and the planet to find the force of the black hole on the planet. I used this method to find all the forces on each object. The velocities of the planet and the ship were determined using the net force on each, and then the position of the planet and ship were determined using the new velocity. As for the results, the ship made it past the black hole with an initial velocity of negative 8.9 times 10 to the 6, and then 7.3 times 10 to the 6, and then 0, and ended up 2.55246 times 10 to the 10 meters away from the black hole. Some possible sources of error are that the time intervals for both experiments could have been shortened for more accurate results. Also, the initial velocity needed for the ship could be different from what I used. I used a method of trial and error to find the velocity, so the velocity I found could not be the best possible velocity. As for the what does it mean question, net force is based on the rate of change of momentum, and in a situation like this experiment, net force cannot be easily found, so the change of momentum is used to determine net force. And for the what if question, by using the x velocity of negative 4 times 10 to the 6 and a y velocity equal to the speed of the planet, the ship was almost able to completely orbit around the black hole.